Today we will start a new lesson, chapter 10, lesson 3, operations with radical expressions. In this lesson, we will learn how can we simplify the sums and differences of radical expressions, and how can we simplify the product and quotients of radical expressions. So we will learn how can we simplify sums, difference, product, and the quotients of the radical. It's like the numerical numbers, it's like any numbers, we can add, subtract, multiply, and divide them. Now, you can use the properties of real numbers to perform operations with radical expression. So the property of real numbers, like you add them, you can use it in the radical expressions. For example, you can use a distributive to simplify the sum or difference. Such as, like if you have 3, now we know before that 3x plus 2x, both of them are multiplied with the same variable. Is it right? 3 is multiplied with x and 2 is multiplied with x. So what does it mean? I can add them and choose one of the x's, or I can take x as a common factor and add 3 plus 2, also you get 5x. So since they are multiplied by the same variable x, you can add them. But if you have like 3x plus 2y, they are multiplied by different variable. Can I add them now?
No.
No, we cannot add them. They have the same. They don't have the same variable, so we cannot add them. In radical, we will do the same. What does it mean? That means if you have 3 square root of 5 plus 7 square root of 5. Now look at the numbers under the square root. Are they the same?
Yes.
Yes. Since they are the same, I will choose one of them here, and then I will add the numbers. 3 plus 7, 10. So it's like 3x plus 7x. You add them, you get 10x, or 10 square root of 5. So here you have the same radicals. Since we have the same radicals or the like radicals, you can add them by combining them. But if you have 3 square root of 5 plus 5 square root of 7. Now look at the number under the radicals. Are they the same?
No.
No.
Yes, grade 8. Are they the same?
No, teacher, they're not the same.
No, they are not the same. So we cannot add them. Like 3x and 5y. Different variable, we cannot add them. For different radicals, we cannot add them. Is it clear?
Yes, teacher.
Yes,
But
miss.
teacher, in the previous lesson, we were multiplying.
No, I have add 3 square root of 5 plus 5 square root of 7. How can we add them? Let's now do this example here. What is the simplified form of each expression? 6 square root of 11 plus 9 square root of 11. Now the first step, look at the numbers under the square root. Are they the same?
Yes.
Yes, we have a square root of 11. Yes. And the second one, we have a square root of 11. So We have 6.
We will add 6 and 9 and take
We have
the
6
first
and we have 9. They are added. But the 6 here multiplied by square root of 11 and 9 times square root of 11. Now they are the same, so we will choose one of them. Then we add 6 plus 9, 15.
15.
So the answer is 15 square root of 11. Is it clear?
Yes, miss, it's easy.
Yes, teacher.
Let's take the second one now. Square root of 3 minus 5 square root of 3. Now, look at the numbers under the square root. Are they the same, the red one?
Yes.
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 So let's take one of them. Then, let's now subtract because we have minus sign. Here, what did we have? What is the number that is hidden here?
1.
1.
1.
Thank you.
1.
So let's now subtract 1 minus 5. 1 minus 5 is
4.
Negative 4.
negative 4.
Negative 4.
So the answer is negative 4 square root of 3.
So teacher, in the subtraction, it's not the problem if the numbers are different.
Now, if it's different, like the numbers under the square root, like this,
If it's I understand.
yeah, they are the same. But if you have like this, of what's this? Let's make it as 2 as an example. We cannot add them because 7 is not like 2, so we cannot add them. They are not like radical. They're not like radical. Sorry.
Okay, thank you, teacher.
Yeah, welcome. Yeah, now let's do this one here. And got it 1. What is the simplified form of each expression? A. We have 7 square root of 2 minus 8 square root of 2. Now look at here, we have the same radical number, so choose one of them. Then let's subtract 7 minus 8.
Negative 1.
Negative 1. So the answer is negative 1 times square root of 2, or you can say it's negative square root of 2. Let's solve B now. Here we have 5 square root of 5 plus 2 square root of 5. Here we have the same radicals. So let's choose one of them. And then let's add 5 plus 2.
7.
7.
7.
Exactly. They are 7 square root of 5. And by now, is it clear?
Yes, teacher.
Yes, miss.
Yes, teacher.
Yes, teacher.
Now, sometimes you need to simplify the radical expressions first to determine if they can be added or subtracted by combining the radicals. What does it mean? Look at this example here. Here we have 3 and 12. If you look at them first, you tell me, teacher, the numbers under the square root are not the same. So we cannot add them. But I will tell you, before you tell me that you cannot add them, ask yourself, is the number under the square root, is the simplified radical? Look at 12.
Yes.
Is it a simplified
No.
radical?
No.
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 So I want now to come back to the second lesson to simplify the radicals, then to see if they are the same or no. So here we have 5 square root of 3 minus square root of 12. As I told you, the numbers under the square root are not the same, but if you look at the second one is not the simplified one. So I can simplify them. How? Let's make a table here for 1 for 3 and 1 for 12. Okay? A table 1 for 3 and 1 for 12. Why 3 and 12? I choose the numbers under the square root. Now, let's write the factors of 3. They are 3 and 1. I don't want it. Factors of 3 is 3. And the factors of 12. Give me 2 factors of 12, but 3 is one of them.
3 and 4.
3 and 4. Is it right now?
Yes.
Yes.
I factor 3 and I factor 12. But when I want to write the factors of 12, I have to ask myself, I want number 3, one of them. So you tell me 3 times 5. So now, after this step, let's come back here. Look at the first one, 5 square root of 3. Now I want to put these numbers, which they are common, under the square root. And the first one, I will keep it as it is. There's nothing I can do it. But in the second one, I want 3 under the square root only. Or you can say, in other words, let's now write here 5. Now what are the factors of 3? 3 and 1. You can say them as 3. Keep it as 3 only. And the second one, we have 12. They are 3 multiplied by 4. Is it right?
Yes.
So after I write the factors of 12, I wrote them under the square root. Let's now distribute them like square root of 3 times square root of 4 and write the first one as it is. Then let's look here. Where can I simplify? Where? Can I simplify square root of 3?
No.
Square root of 4?
No. Yes.
Square root of 4?
Yes.
So here I said it's 2 square root of 3. And at the first, we have 5 square root of 3. Now look at the final answer after I simplified them. After that, now look at them. Can I subtract them now?
Yes.
Yes.
Yes, we have the same
Yes.
numbers under the square root. So we can subtract them. We choose one of them. And then we subtract 5 minus 2, which is 3. Is it clear?
Yes, teacher.
Yes, miss.
Yes, teacher.
Let's have another example.
Teacher, can you return for the question just 1 minute?
Yeah.
Please, 1 minute just.
Okay.
So teacher, we will simplify, then we will combine the verticals.
Sorry?
Correct? Means we will simplify, then we start to add or subtract.
Yes, exactly. We have to simplify them. Then we can combine them. Why? Because I cannot judge that we cannot add them from the first because 12 is not a simplified one. But if we come back here, did you see the numbers here? I wrote them. I wrote 5 and 7, but 5 and 7 is the simplified one. We cannot simplify them as we said before. So that's why we say, I told you we cannot add them.
Okay.
Yeah. Now,
I think
this got it here. What is the simplified form of each expression in A and B? 4 square root of 7 plus 2 square root of 28 and 5 square root of 32 minus 4 square root of 18. Let's now do A first. 4 square root of 7 plus 2 square root of 28. Now, as you see, the numbers under the square root are not the same. We have 7 and we have 28. Let's make a table here. 1 for 7 and 1 for 28. Now, what are the factors of 7? We have 7. We can 7 and 1, keep 7 only. And we have 28. Now, give me 2 factors, but 7 is one of them. 7 and what?
7 and 3 and 4,
7 and
4,
4.
4.
Exactly. 7 and 4. Then, after that, let's now write or rewrite them. We have 4 square root of 7 plus 2. Now, square root is, and instead of writing 28, I have to write 7 and 4.
So put 4 square root of 7.
Then, let's now distribute it like this. Plus 2. Now, can I simplify square root of 7 or square root of 4? Which one?
Square root of 4.
Square root of 4. What is the square root of 4?
2.
2 square root of 7. Then after that, let's multiply 2 times 2, which is 4 square root of 7, plus the previous one, which is 4 square root of 7. After you add them, you will find that they are 8 square root
8 square root of 7.
Exactly. Is it clear?
Yes, miss.
Yes, teacher.
Let's have another example here. In B, we have 5 square root of 32 minus 4 square root of 18. As we say now, look at the numbers under the radical. Are they the same?
No.
No. So let's now take the 32, make a table here for 32 and for 18. Now, I want you now, when you factorize the both of these two numbers, give me a factor that they are common between them. Like, you know that 32 is 16 and 2, 8 and 4. 18, we have 6 and 3, 9 and 2. Now, I want you now to choose 2 pair of factors that they have one of the numbers are common. Which pair of factors?
2 and
I will
16
repeat.
and 9 and 2.
Thank you. I will repeat. I will choose one pair of numbers and one pair of factors. These are the two pairs for 32. They are the blue one and the red one for 18. I want you now to choose one from the blue and one from the red that they have a common numbers between them. Which two pairs?
9 and 2.
9 and 2 and 2 and 16.
Exactly. These have a number 2 between them. So we have 2, 16, and 9 and 2. This is the first step. Now let's come back. 5. But no, instead of writing 32, I have to write 2 and 16. Then minus 4. Instead of writing 18, I have to write 9 and 2. Let's then distribute the square root into the two numbers here. Yeah, 5. What is the square root of 16?
4.
4. 4 times the square root of 2 minus 4. What is the square root of 9?
3.
3 square root of 2.
20.
Let's now multiply them. 5 times 4,
20.
20
20.
square root of 2 minus 4 times 3,
12.
12 square root of 2. Now look at the numbers under the radical. Are they the same?
Yes.
Are they like radical? Yes, so let's choose one of them. Then let's subtract. 20 minus 12 is
8. 8.
So the final answer is 8 square root of 2.
Yes, teacher, I have a question.
Yes, Farah.
In number 8, teacher, one of the numbers was a multiple to the other number. But in number B,
Yeah, in number
That's
B,
what-
they are not, but I want to choose a factor that they are common. Why? To make them here have the same radicals. That's why I asked you, give me two factors of 18 and 32 that have at least one pair of one numbers that they are common. To make them like this, that's can we add or combine them.
okay.
Yeah, let's do now these examples here. I have these 6 examples. Inshallah, we can do it in this lesson. Yeah. Number 9 here. Square root of 5 plus 6 square root of 5. Now look at the numbers under the square root. Are they the same?
Yes,
Yes.
they are
So
the same.
we will choose one of them and then let's add. Here we have 1, which is hidden. 1 plus 6 is
Yes, because 7.
7. So it is 7 square root of 5. Now let's do number 10. 12. Now, number 10. Here we have 12 square root of 5 minus 3 square root of 5. Are the numbers under the square root the same?
Yes.
Choose one of them. Then let's subtract. 12 minus 3 is
9.
9.
So the final answer here is 9 square root
The
of
square root of 5.
Let's do now number 13.
Okay.
In number 13 here, we have 3 square root of 7 minus square root of 63. As I told you now, if you look at them, you will see that, teacher, they are not the simplified ones. They are not the same, so we cannot subtract them. But the number 63 is not a prime number. We can factorize it. It's not the simplified radicals. So what we have to do, let's now make the table and find the numbers that they are common. What are the numbers under the square root? We have 7 and what? 63.
63.
Yes. Now what are the factors of 7? We have 7 and 1. 63, I want you now to give me, oh, let's write the factors of 63. We have 7 and 9. And we have also, I think, 63, we have 21 and 3, is it right?
Yes.
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 These are the factors of 63. Now, I want you now to choose which from these blue factors have a common number with the green one.
7 multiply 9.
7, 9.
7, 1 and 7, 9. Exactly. Then let's write them here. So we have 3 square root of 7, because 7 times 1, you need to write number 1, minus 63. But no, instead of writing 63, write 7 and 9. Then let's now distribute the square root. 7 and 9. Then 3 square root of 7, keep it as it is. Now what is the square root of 9?
3.
3 times square root of 7, which is the
Equal almost square root of 7.
which is equal what?
Square root of 7.
0.
Teacher, why 0? But teacher, 3 and
0. Okay, teacher.
3?
3
why
minus
is 3?
Here you said it is square root of 7.
Only, yeah.
Okay, and 3 minus 3?
0.
0. 0 multiplied by 0 square root of 7?
0.
0. Yeah.
Okay, teacher.
Okay, let's do now number 14. In number 14 here, we have 4 square root of 128 minus, plus 5 square root of 18. Now, let's now make a table for 128 and for 18. Now let's write all the factors of 128 and of 18, but they have a number that they are common between them. I will help you. Yeah. 19, we have 9 and 2. We have 6 and 3.
And 128 teacher should be 2 and 64.
Sorry?
And the factors of 128, there's 2 and 64.
Yes, here we have 2 and 64, and we have, right, we can say also 16 and 8. So, these are the factors of 128. Now, choose one from the red and one from the blue.
To put the one in the
Have a number in common. What are they?
2 multiplied by 64.
And 2 multiplied by 64.
264 and 92.
9 and 2.
So no, 2 and 64 and 2 and 9. Let's now rewrite them here. 4, but now instead of writing 128, let's write them as 64 times 2 plus. Here now we have 5, but instead of writing 18, write them as 9 times 2. Is it right?
Yes.
Then let's now distribute the square root on the numbers here, on 64 and on 2 and on 9 and on 2. What is the square root of 64?
8.
8, exactly. Square root of 2 plus 5. What is the square root of 3? Of 9, sorry, it's 3. I answered 3 square root of 2. Let's now continue here. 4 times 8.
32.
32 square root of 2 plus 5 times 3.
15.
15 square root of 2. Now look at the answer that after I simplify it. Did I get the same radicals?
Yes.
Yes, so I can now add them by choosing one from these numbers like this and then add these two numbers. 2 plus 5 is 7, 1 plus 3 is 4. Is it clear?
Yes.
Yes, teacher.
Yes, miss.
Okay. Now, let's do now number 17. Negative 6 square root of 10 plus 5 square root of 90. Now, here the numbers under the radical are not the same, so let's make the table here. Here we have 10, here we have 90. Now, as I told you before, where should I stop? If it is 10, if it is a prime number, or their product is a prime number, or their factors are a prime number, so I can say that this is the simplified one. So is 10 is a simplified one?
Yes.
Yes, miss.
because it is keep it as 10. We cannot say that it has a square root on one of its factor. And 90, I want you to write the factors of 90, but 10 is one of them. Which pair of factor you have to choose?
9 and 10.
9 and 10,
10 and
exactly. Let's now rewrite it here. We said it is negative 6 square root of 10 plus 5, but instead of writing 90, write 9 times 10. Then negative 6 square root of 10 plus 5. Now let's distribute the square roots here. 1 for 9 and 1 for 10. We can say it's square root of 9 times square root of 10. What is the square root of 9? 3. And the square root of 10, keep it as it is. Then, as we see now, the number under the radicals are the same. So that's what I want. Let's now here write them as 5 times 3, it is 15, square root of 10. And here we have negative 6 square root of 10. Now the numbers under the radical are the same. So let's write them here. And then let's add negative 6 plus 15 is?
It will be 9.
9, exactly. So the final answer is 9 square root of 10. Is it clear?
Yes.
Yes, teacher. Yes, miss.
Now here I have only 1 minute, so I will do number 18. We have 3 square root of 3 minus 2 square root of 12. I will make the table here for 3 and 12. 3 or 3 and 4. Then we have 3 square root of 3 minus 2. But instead of writing square root of 12, I have to write 4 and 3. Then let's have 3 square root of 3 minus 2. And here, as we did before, we distribute the side, this one and these two numbers. So we have 2 square roots of 3. Multiply them 4 square root of 3 and 3